they gave us the power series that represents the function h. And the first question says, write the first 4 terms in the general term. This should be pretty easy. All we're going to do is grab a random color. What color should I grab? Green. I'm going to grab green, and we are going to plug in 1, figure it out, plug in 2, figure it out, plug in 3, figure it out, plug in 4, figure it out, put a few spaces, plus dot, 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 and then just write this, because this is the general form. So let's plug in a 1. When I plug in a 1, I will have -1, that's negative, so I have a negative. Plug in a 1 there, that gives me x minus 1 to the 1, divided by 1 cubed. That is my first term, in a sense. You could distribute and say, well, I have 2 terms here, but just in terms of what we're doing, terms, get it? That's what I would have. So if you wanted to, you could grab a purple pen and say that this is where n equals 1. Okay, let's plug in 2. When I plug in a 2, I've squared a negative. That gives me a positive, so we're dealing with a positive, and therefore x minus 1 is to the 2nd over 2 to the 3rd, which of course is 8. All right, that's where n equals 2. You don't have to do this at the bottom of each term. Equals 2. All right, let's keep going. We're going to plug in a 3. Plug in a 3 right here. It's going to give us a negative. And then x minus 1 to the 3rd over 3 cubed. That's 27. That's where n equals 3. And then we'll do number 4. So we plug in a 4, get an even exponent. Negative to an even is going to give me, well, positive. So and positive, and then x minus 1 to the 4th over 4 to the 3rd, which is 64, just to complete the pattern of what I've been doing. This is where n equals 3, and this is where n equals 4, and we'll keep going with this. So we would go and go and go, and when we do, we end up with the general term, which is what they gave us, which is no surprise whatsoever, and then it goes beyond that. All righty. Let's continue this process with the next question where they say find h prime, and it's really the same thing. Find the first 4 non-zero terms in the general term. So we're going to take the derivative of this term, this term, this term, this term, and the general term. So here we go. Switching colors, switching to blue. H prime of x is, let's see, the derivative of this term, that'd be negative x plus 1, so that'd be negative 1. All right. The derivative of this term, so 1/8 times 2, that's a 4th, 1/4, and then we'll subtract 1 from this exponent, and technically it's a chain rule issue, but the derivative of that inner function is just 1. All right, negative 1/27 times 3 is 3/27, that's 1/9, but it is negative. X minus 1 is squared, and then 1/64 times 4 is 1 over 16, so 1/16. X minus 1 cubed. I hope you notice the pattern here. Notice the denominators are 1, 4, 9, 16. They were perfect cubes, now they're perfect squares. And it makes sense because you divided by that exponent. That 64 got divided by 4 when it was reduced, and that gave you, what, 16. So plus dot, 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 and you're about to see that happen here. So what I'm going to do is take this coefficient, negative 1 to the n over n cubed, and I'm going to multiply it by n. I'm going to show a little bit of work here on a scrap piece of paper. Let me show you what we're dealing with. So if I had negative 1 to the n over n cubed, and then I have x minus 1 to the n, and I'm taking the derivative, I would do negative 1 to the n times n over n cubed. And the thing I said a minute ago about how the exponent ends up being, notice my exponent went down by 1. The exponent ends up being squared in the denominators because that cancels with that and makes it squared. So this is the general term at this point. So here we go. We're going to have negative 1 to the n over n squared, and it makes so much sense. I said it a minute ago. The denominator is 1, 4, 9, 16, n squared. And then x minus 1 to the n minus 1. All right, now let's find an integral. And in doing this, we're going to do a lot of writing. Let's write this one in red just for fun. So k of x equals the integral from 1 to x of h of t dt. And then it says write the first 4 terms and the general term. So I'm going to actually write this here, but I'm going to use t's instead of x's because I need to watch my variables kind of closely. So negative x minus 1, whoops, and there I just said it. And what did I do? I wrote an x instead of a t. It's a habit. Habit with a t. All right, plus 1/8 t minus 1, t minus 1. I'm having a hard time here. Let's make that look a little neater. I'll tell you what, it's a struggle. T minus 1, it is squared, minus 1 over 27. T, we're going to make it a t. T minus 1 cubed. I'm going to get one of them right at least. Plus 1 over 64. Here we go. T minus 1 to the 4th. Plus ... And we keep going. And we have negative 1 to the n over n cubed. And then t minus 1. T. Thankful for whiteout. T minus 1 to the n plus ... All that integrated with respect to t. Wow, what a mess. What a mess, because x's and t's got mixed up. We're going to take the integral of each of these terms, and you've taken integrals before. It's really no different, so let's do this. Now, keep in mind that as we do this, we're integrating with respect to t, so I better still write t's, and then we're going to evaluate this from 1 to x. This is a definite integral, so no c necessary. That would be an indefinite integral. Sorry, my chair just popped. All right, antiderivative of 1, t minus 1 would be, well, t minus 1 squared, and then old coefficient divided by new exponent, so negative 1/2. These are going to be pretty straightforward. And then next term, t minus 1, and it is cubed. 1/8 divided by 3, well, that would be 1 over 24. That one's positive. All right, going to add this exponent, t minus 1, that's 4. Sometimes it helps to do these general ones. Sorry, it helps to do the first 4 terms or 3 terms or ever how many. So when you get to the general term, you'll be able to identify patterns a little bit easier. So 1 over 27 divided by 4 is going to be, well, 27 times 4. 27 times 4 is 108. Now they're getting less obvious. And then t minus 1 to the 5th. 64 divided by, 64 times 5, or 1/64 divided by 5 would be 1 over 64 times 5, which is 320. There's that. And then we'll keep going forever. We're about to get to the general term. So we are going to add 1 to this exponent, which makes it t minus 1. T. Struggle is real. T minus 1 to the n plus 1. And now we're going to have old coefficient divided by new exponent. So it gives me negative 1 to the n over n cubed n plus 1. And it goes on forever. But definite integral from 1 to x. Okay, that was a lot of writing. I could have skipped this step, but I didn't want to because there's some amazingness that's about to take place. This one was specifically engineered for this power series that is clearly centered at 1. I hope we've noticed that up to this point. If you haven't, that's okay. But clearly centered at 1. So when I plug in x, basically I'm going to have all the stuff with x's, now that I've gotten the habit of writing them with t's. And when I plug in a 1, I get 0 and 0 and 0 and 0. So I don't even need this. It's like plugging in 0 to a polynomial, but now I'm plugging in a 1 when I'm subtracting 1, and it becomes 0. So, final answer right here. Negative 1/2. X goes in for all my t's, so x minus 1 squared plus 1 over 24. X minus 1 cubed minus 1 over 108. X minus 1 to the 4th. 1 over 320. X minus 1 to the 5th plus blah, blah, blah. Negative 1 to the n cubed, n plus 1. And then x minus 1 to the n plus 1 plus, and it goes forever. And you plug in the 1s and you get 0s. You have just taken the integral of a series.